And today I'm going to be talking about the antebrachium or forearm. And just as a reminder, we talked about this in the previous lecture, that anatomists have kind of a strange usage of the word arm. When an anatomist talks about the arm, they're referring only to what we would call the upper part of the arm, which is between the shoulder and the elbow. And then everything from the elbow down to the wrist would be the forearm. Now, we're all familiar with the term forearm, that makes sense, but very few of us are accustomed to using the word arm to just refer to the upper part. Usually when we talk about arm, we can think about the whole thing. So for that reason, just because of the ambiguity about the meaning of the word arm, I prefer to use the Latin terms instead. So I use the term brachium for the upper part of the arm and the term antebrachium for the forearm. And you'll hear me, I switch back and forth sometimes. I'll call it forearm or antebrachium, but generally I prefer to use the Latin term because I think it's less ambiguous. By the way, note the spelling of the word antebrachium. It's not A-N-T-I brachium, because A-N-T-I, that Latin prefix would mean opposed to or against the brachium, like against the arm. This is A-N-T-E, which means comes before. There are terms that are not used very often in the English language, but there's a term antediluvian, which means before the flood, referring to Noah's flood from the Bible. In the U.S., there's a term antebellum, A-N-T-E, bellum. Bellum in that case means war or fight. Antebellum refers to the period prior to the U.S. Civil War. So there are other uses of this prefix, A-N-T, meaning something that comes before. So this literally translates into forearm or before the arm from the Latin. Right, so we talked a little bit about the humerus last time, as well as talking very briefly about the proximal end of the radius and ulna. We went over those bony landmarks in the distal part of the humerus and the proximal landmarks of the radius and ulna last time. So I'm not going to go over those again today, but I did want to add in the remaining bones of the upper limb, simply because a lot of the muscles that we're going to talk about today, the muscles that are found in the antebrachium, the majority of them are crossing the wrist and inserting on some of these bones in the wrist and in the hand, and they're responsible for the movements of the wrist and the fingers in the hand. So we need to understand what these bones are before you can understand what the actions of a lot of the antebrachial muscles are. Remember that there are two bones in the forearm, in the antebrachium, the radius and ulna. In the fully supinated position, which would be standing in anatomic position, these two bones lie parallel to one another. And in anatomic position, the radius is always going to be lateral. So remember that little mnemonic that someone shared on the RIT listserv. Radius is thumb, RIT, referring to the fact that the radius is the more lateral bone of the antebrachium, and it's on the same side as the thumb. The ulna is the more medial of the two bones, so that would be facing medially or towards the rest of the body, and that would be found on the same side as the fifth digit or pinky finger. Just distal to the radius and ulna are a group of 8 little bones called carpals. We'll come back and talk about the carpals in more detail in my next lecture when I talk about the bones of the hand and the wrist in more detail, when we talk about the muscles that are actually found in the hand. But I just wanted you to be aware that there are these 8 little bones called carpals that are found in the wrist area. By the way, there are actually only 2 carpal bones that really form the true wrist joint. We'll describe these next time in more detail, but you may be able to look closely at this and see that only 2 of those little carpal bones are actually making contact with the distal end of the radius. And that's the main joint where most of the movement of the wrist occurs. Just distal to the carpals are a group of 5 bones called metacarpals. Now these bones look like they belong to the fingers, and there are 5 metacarpals, just like you have 5 fingers. But these bones do not extend out into the fingers themselves. These are the bones that make up the flat part of the hand. And if you feel the center of your own hand, you can actually identify them individually and tell that there are, in fact, 5 bones in there making up the flat part of the hand. The metacarpals then articulate with bones called phalanges, which are the ones that actually make up the fingers and the thumb themselves. In the thumb, which is what we call digit 1, the thumb is the first digit in the hand. The thumb only has 2 phalanges. And some more obscure Latin terminology. This one's very confusing because it doesn't sound like it makes any sense at all. But the singular, phalanges is plural, the singular is phalanx. So if you're looking at or talking about just a single one of these little bones out in the fingers, each one of them is a phalanx. And collectively, the plural is phalanges, just an obscure Latin pluralization. So the thumb only has 2 phalanges. There's a proximal phalanx connected to the metacarpal, and then a distal phalanx out at the tip of the thumb. The other 4 digits, which would be numbered digits 2 through 5, the 5th digit being the pinky or little finger, those other digits all have 3 phalanges. So each of those has a proximal phalanx, a middle phalanx, and a distal phalanx. Let's talk a little bit about the joints between these different bones, because the muscles of the antebrachium are going to be moving these bones, so that the muscles are going to be crossing certain joints and acting on certain joints. There are actually a series of joints between the radius and ulna themselves. These are referred to as the radio-ulnar joints. There's a proximal radio-ulnar joint, which is up by the elbow, and that's a joint that's formed between the head of the radius and a little notch on the lateral side of the ulna. And as the forearm goes through these motions of pronation and supination, where the radius is rotating relative to the ulna and crossing over the ulna, this proximal radio-ulnar joint is just sort of pivoting in place. Imagine that head of the radius as being just a little disc that rotates around against that fossa on the ulna. Down at the distal end of the ulna and radius is what's called a distal radio-ulnar joint. And you'll see on the next slide the kind of motion that occurs here. But at this distal radio-ulnar joint, the entire distal end of the radius crosses all the way over to the other side of the distal end of the ulna. I'll jump ahead just so you can see that more clearly. You see here what happens during pronation of the forearm. The distal end of the radius swings all the way over to the opposite side of the distal end of the ulna. The ulna is completely stationary during these movements. The ulna doesn't move at all during pronation and supination. That motion is entirely movement of the radius, with the radius crossing over the ulna and swinging across it so that the 2 bones end up in this kind of X shape. So when you pronate the forearm, at the proximal radio-ulnar joint, the head of the radius is just kind of rotating relative to that little notch in the ulna. But down at the distal end, the whole entire distal end of the radius swings all the way over to the opposite side of the ulna. Going back to the previous slide, the third joint between these 2 bones is really a different kind of joint, but technically it is a type of joint. The interosseous membrane is a very tough fibrous membrane that holds the shafts of the 2 bones together. This is known as a fibrous joint, so it is actually a true type of joint. It holds the bones tightly together so that you can't separate the radius and ulna from one another, but at the same time, it's very flexible, so it allows the bones to move relative to one another during pronation and supination. So right here, you're seeing the fully supinated position, which would be anatomic position where the 2 bones are parallel to one another. And then here you see the pronated position of the forearm, where the radius swings across to the ulna, other side of the ulna, and the two bones are kind of crossing one another like a big letter X. By the way, the hand is simply doing whatever the radius does. Remember, I mentioned briefly just a minute ago that two of the carpal bones in the wrist articulate with the distal end of the radius. They form a joint between the radius and the carpal bones. So what that means is that the hand, the entire hand, is tightly attached to the radius and not very tightly attached to the ulna. So whatever the radius does, the hand just kind of goes along for the ride. So the main motion that's visible when you pronate and supinate the forearm is the movement of the hand. But really the motion of pronation and supination is happening between the bones of the forearm. The hand just goes along for the ride. Whatever the radius does, the hand just moves with it. Taking a look at some of the other joints that are found in the upper limb. These would be the remaining joints that lie out in the wrist and in the hand. And there's quite a few of them, and each of them has their own kind of unique sort of motion. There's a joint known as the radiocarpal joint. This is one that I already mentioned briefly. It's the joint that's formed between the distal end of the radius. So imagine the radius coming down like so. And then two of the 8 carpal bones in the wrist. And we'll come back and talk about these in more detail in the next lecture. That's the primary wrist joint. That's where most of the motion occurs that we think of as happening in the wrist. And I'm going to see if I can stop sharing the screen here for a second so you can see me. So there are a couple of different kinds of motion. I'm going to turn off that background image so that you can see me a little better. So the radiocarpal joint is this, wrong hand, is this joint right in here. The radius is over on my thumb side, and the ulna is over here on the medial side. So that would be, medial and lateral in anatomic position, like so. The radiocarpal joint that's formed between the radius and two of the carpal bones in my wrist, that's responsible for most of the movement of the wrist joint. So one kind of motion that occurs there is flexion and extension. So flexion is simply decreasing the angle between the forearm and the hand, and extension would be increasing that angle between the forearm and the hand. Most of that motion occurs at that radiocarpal joint. The other motions that occur at that radiocarpal joint are abduction and adduction. And I got to back up more so you can see me. Or maybe I'll stand up. Maybe that's easier. So just like with any other kind of abduction and adduction, abduction is rotating something away from the midline of the body. So the hand can actually rotate away from your body a little bit. So this would be abduction with a B. And then adduction with a D would be rotating the hand towards the midline of the body. So this is another motion that's occurring primarily at that radiocarpal joint. And those are the only motions that occur at that joint. You can't take the hand and actually twist it relative to the radius. As my hand is moving around, it's really just because the radius is moving. There's no rotation occurring between my wrist and my forearm. The next joint in the wrist is actually called the midcarpal joint. And this really isn't just one joint. It's actually a whole series of joints. It's a series of joints between the bones in the proximal row of carpals and the bones in the distal row of carpals. The 8 carpal bones are arranged into 2 rows, so that there are 4 carpals that are more proximal, closer to the forearm, and 4 bones that are more distal, farther away from the forearm. And so the midcarpal joint represents a series of joints between each bone in the proximal row and each bone in the distal row. There's really not a whole lot of motion that occurs at this mid-carpal joint, so you don't really have to worry too much about that particular motion or about the, what's happening at that particular joint. There's also a set of joints called carpometacarpal joints, or CMC. These are the joints between the carpals, specifically the distal row of 4 carpal bones, and then the proximal end of all 5 metacarpal bones. Most of these joints don't move very much. Let me stop sharing again and go back so you can see me. So these joints are right down here. The carpals, sit in the wrist area, and then they articulate with the metacarpals here down near the base of the hand. And if you were to grab, say, your index finger, which is digit 2, grab it in the middle of your hand here and try to wiggle that bone around relative to your wrist. That bone really doesn't move very much at all. Maybe you can move that bone a few millimeters, but that carpometacarpal joint of the second digit is way back here, between the carpal bones and the metacarpal bones. It hardly moves at all. So most of these carpometacarpal joints have very, very little motion. Now, if you grab your hand out here near the base of your pinky finger and you wiggle that back and forth, that moves a little bit more. I can move that metacarpal bone maybe a ½ inch forward and backward. That again is occurring down here at that 5th carpometacarpal joint, but still it's very little motion. So the carpometacarpal joints from digits 2 through 5, here in the flat part of your hand, they move very little at all. The only one that really moves with any significant amount is the 1st carpometacarpal joint, which is a joint that's formed between the trapezium, which is one of the distal row, and the 1st metacarpal, which is the metacarpal of your thumb right here. And at that joint down here between the base of the thumb and the wrist, you can actually do things like this, which this motion is actually abduction of the thumb, where it points forward away from the flat plane of the hand, and then adduction of the thumb is bringing it back so it lies within the flat plane of the hand. So there's that kind of motion. There's also extension and flexion, and a lot of that motion is occurring here at that 1st carpometacarpal joint. So that's the only one where, I'm sorry, question?
Yeah. What's the difference between abduction of the thumb and opposition? Is opposition when it's actually touching, like,
when it's touching the other fingers. So opposition would be this motion of reaching across the palm to touch the other fingers, to touch the tips of the other digits. Opposition is really a combination of multiple movements. Typically, when you oppose the thumb, you abduct the thumb first, so it points out away from the rest of the hand. And then you flex the thumb, which brings it across the palm to touch the tip of your pinky finger. Now, there is a third little motion that's occurring in there. There is actually a rotational motion occurring in that 1st metacarpal, which only happens during opposition. So opposition is somewhat unique, but for the most part, opposition just requires abducting, flexing, and maybe even adducting a little bit, because you're kind of pulling the thumb back towards the hand and then touching the tips of the fingers. Good question. Let me share the screen again. So just to summarize what I was talking about, the 4 of those carpometacarpal joints, associated with digits 2 through 5, they don't move hardly at all. It's really only that 1st carpometacarpal joint at the base of the thumb that has any significant amount of motion. The next set of joints in the hand are the metacarpophalangeal joints. I know these names are very long and they're tongue twisters, but if you really think about what the name means, it's actually kind of simple. These are the joints between the metacarpals and the phalanges, so hence metacarpophalangeal joints. These are the joints between the metacarpals and the proximal phalanx of each digit, And so this is where the fingers move relative to the hand. So once again, I'll stop sharing. So those would be the ones out here where your knuckles are, where the hand meets the fingers. And the metacarpophalangeal joints are capable of two different kinds of motion: flexion, extension. So flexion, reducing the angle between the fingers and the hand, and extension, increasing that angle. The other motion that occurs at these metacarpophalangeal joints is abduction with a B and adduction. So abduction with a B refers to not moving the fingers away from the midline of the body, but moving the fingers away from kind of an imaginary midline drawn down the center of the hand. So it actually runs right down the center of the middle finger, is the sort of imaginary central axis of the hand. And so when you spread the fingers away from the middle finger, we call that abduction or abduction, and then bringing them back towards the middle finger is adduction. Now the thumb is a little weird because the thumb has rotated 90 degrees during embryonic development. So the motions of the thumb are different from the motions of the fingers. So you might think that, oh, if this is abduction of the fingers, then maybe this is abduction of the thumb, but that's not true. Abduction of the thumb is actually this motion. It's sort of perpendicular to that other motion, where the thumb points out away from the flat plane of the hand. And then adduction refers to bringing it back so it lies in the same plane as the rest of the hand. And then flexion and extension of the thumb. Flexion is sort of curling the thumb like this, and extension is straightening it out again. So this is flexion and extension of the thumb, and then this is abduction with a B and adduction of the thumb. So quite different from the other digits. You know, with these digits, this is abduction and adduction, and then this is flexion extension. And then finally, before I go back to the slides, I'll just mention the other joints since I want to demonstrate them for you. Then you start getting out into what are called interphalangeal joints. In other words, joints between the phalanges in the digits. The thumb only has a single interphalangeal joint. So we just call it the IP joint or interphalangeal joint. It's a joint between the proximal phalanx here and the distal phalanx out of the tip of the thumb. And all of these interphalangeal joints just do one thing. They just flex and extend. The other digits, digits 2 through 5, since they have 3 bones in each finger, or 3 phalanges, proximal phalanx, middle phalanx, and distal phalanx, there's actually 2 sets of joints in these other fingers. So there's a joint right here that lies between the proximal phalanx bone and the middle phalanx bone. This is known as the proximal interphalangeal joint because it's more proximal, closer to the rest of your arm. And then out here is a distal interphalangeal joint that lies between the middle phalanx and the distal phalanx. These are often abbreviated. Proximal interphalangeal joint is the PIP joint, and distal interphalangeal joint is the DIP joint. And I have to kind of stabilize my hand here because it's a little hard to do this. Well, I can flex and extend my PIP joints by themselves, but it helps if I hold the other one steady. You know, so there's flexion and extension of the PIP joint of my little finger. And then the DIP joints, that's almost impossible for me. Some people seem to be able to do that, but imagine, you know, trying to flex and extend that DIP joint without moving the other joints. So here's flexion, and I still can't hold it quite stable, but there we go. So there's flexion and extension of the distal interphalangeal joints, or DIP joints. So lots of different motions to be familiar with, but it's important because the muscles of the forearm are going to act on these joints. All right, so let's move on to talk about the muscles of these joints. And here we have a series of cross sections through the forearm. And this is very similar to what I showed you with the brachium. before, if we zoom in on one of these cross sections, we see that there's something very similar here in the forearm to what we saw in the brachium. You remember in the brachium, all the muscles were divided into two compartments, an anterior and a posterior compartment. So in the brachium, you've got biceps brachii, coracobrachialis, and brachialis muscles in the anterior compartment. And then in the posterior compartment, you have triceps and anconeus on the back of the arm. So there's a similar division here in the antebrachium as well, but it's a little different because what's happened here in the antebrachium is that many of the anterior muscles have migrated medially around towards the medial aspect of the ulna. So you notice how that anterior compartment is shifted towards the right side of the slide, which would be in the medial direction towards the ulna. And at the same time, the posterior compartment muscles have migrated the other directions. They've kind of migrated laterally a little bit to the point where at least one of the lateral compartment muscles has wrapped all the way around the lateral side of the forearm so that it actually lies in a more of an anterior position. So we're going to take a look at the muscles in these compartments, starting with the anterior compartment. So here's a superficial view of the muscles in the anterior compartment. I'm just getting my drawing tools here. An important thing to note about these superficial muscles is, well, first, a couple of things. This muscle over here on the lateral side called brachioradialis, this is actually one of those muscles that belongs to the posterior compartment of the forearm. I mean, it's sitting right here in front. It's in the anterior surface of the forearm, but embryologically, it develops with all of those posterior compartments. In fact, it's contained within a fascia envelope along with all of the posterior muscles. It's just that during development, it's kind of wrapped around here, around the lateral side, all the way to the front. So I'm going to talk about it now, even though technically it's a posterior compartment muscle, because you can really only see it here from the front of the forearm. The brachioradialis has its origin way up here on the humerus. It's originating from a ridge on the humerus known as the lateral supracondylar ridge, which we talked about in an earlier lecture. And it crosses the elbow joint up here. And then if you follow it distally, way down here, it does not cross the wrist. The name brachioradialis means it goes from the arm to the radius. It's actually inserting at the distal end of the radius down here, just above the wrist. So that means it's only crossing one joint. It's only crossing the elbow joint. And this is a flexor of the elbow. So this muscle actually helps the biceps and the brachialis flex the elbow. The brachioradialis is innervated by the radial nerve, which is the nerve that innervates all of the posterior structures of the brachium and antebrachium. So that's another clue to the fact that this is really a posterior compartment muscle because it shares its innervation with all of the other posterior compartment muscles. So that's radial nerve. So over here on the other side of the slide, we see the other, the true flexor muscles. Whoops. These are the muscles that are actually part of the anterior compartment, or the true anterior compartment. These are arranged in a couple of different layers. So what we're seeing here is just the superficial layer, and then there are some deeper muscles as well. One thing about a lot of these anterior compartment muscles, many of them have their origin from something called the common flexor tendon. This is a tendon that originates from the medial epicondyle of the humerus. So I mentioned before about how a lot of these anterior muscles are shifted more towards the medial side. And it makes sense that a lot of them are actually originating from this epicondyle on the medial aspect of the humerus. And then they all kind of radiate out from that point and become separate. But right at their origin, many of these muscles are fused together coming from that common flexor tendon on the medial epicondyle of the humerus. Sometimes it can be very difficult to identify these muscles because they're all so close together, and because of the fact that they are fused together up at their origin on that medial epicondyle. So the best way that I found to identify these muscles in the laboratory, and in particular on a laboratory exam, is that you have to start from some reference point and then work your way across the forearm, either working from lateral to medial or going from medial to lateral. What I like to do is when I first walk up to a cadaver and I'm looking at the forearm and I'm trying to orient myself, I'll look for that brachioradialis over on the lateral side. And remember, lateral is thumb, radius is thumb. So the thumb would be down here on the lateral side of the hand. So the first thing I have to do when I walk up to a body is I have to look for the thumb to orient myself. Which side of the forearm is lateral, which side is medial? Once I've determined what's lateral, then usually this brachioradialis muscle is pretty easy to spot. And then I'll start at that point, and then I'll gradually work my way across, working from lateral to medial, working my way across the muscles of the anterior compartment. So if I start lateral and work my way medial, the very first muscle I'm going to come to is this one up here. And I apologize, I can't see my cursor, so I never know what I'm drawing on. There's a muscle called the pronator teres. That's originating partly from that common flexor tendon, but it also has part of its origin even higher up. There's something called the medial supracondylar ridge up here, which is also part of the origin for pronator teres. The muscle crosses the forearm diagonally, and you can't see it, but over here, deep within the forearm, the muscle is inserting on the shaft of the radius. Based on its name, you may be able to tell what its function is. Teres just means round, but the word pronator tells you what this muscle does. It's a pronator of the forearm. So what it's doing is it's pulling on that radius and pulling the radius in a medial direction, which is going to have the effect of getting that radius to swing across to the medial side of the forearm, which is that motion of pronation. So that's what it does. I'll come back to the innervation of these in a minute. Then continuing to work our way from lateral to medial across the forearm, the next muscle we come to right here is flexor carpi radialis. That's another one that has its origin on that common flexor tendon. If you follow its tendon down into the hand, it actually crosses the wrist and eventually has its insertion on the second and third metacarpals in the hand. So this muscle is actually crossing more than one joint. Remember that common flexor tendon up here is on the humerus. So this flexor carpi radialis muscle is actually crossing the elbow joint up here, but it really plays almost no role in movements of the elbow. Its primary motion is down here at the wrist, if I can find the wrist. There it is. This is a flexor muscle of the hand at the wrist joint, and that's where it gets its name. Flexor tells you that it's flexing something. The word carpi is the Latin word for hand. If you've ever heard the expression carpe diem, that means seize the day or grab the day, and it's coming from the Latin word for the hand. So a flexor carpi is a muscle that flexes the hand at the wrist joint. Radialis is referring to the fact that this muscle is inserting on the hand more on the radial side, a little bit more on the lateral side. So it's inserting on the second and third metacarpals, which are a little bit closer to the lateral side of the hand. So it's a flexor of the hand that inserts on the radial side. So origin from common flexor tendon, insertion on metacarpals 2 and 3 in the hand. And it's going to flex the wrist, flex the hand at the wrist joint. The next muscle working our way across the forearm is called palmaris longus. The palmaris longus is another one that has its origin up on that common flexor tendon. And it has a long, skinny tendon that runs through the forearm. And when it gets down into the hand, it kind of fans out and spreads out to form a structure called the palmar aponeurosis, which is just a tough sort of fibrous sheath in the center of the palm. Interesting thing about palmaris longus muscle is that it's missing in, I've heard different numbers, but most books will say missing in about 14% of the population. So it seems to be a muscle that's disappearing over the course of human evolution. Even if you do have a palmaris longus, more than likely it's quite small. It has a very small muscle belly and a fairly long, skinny tendon. And in many people, it may be absent completely. All right, the last of these superficial muscles is called flexor carpi ulnaris. Oops, if I can find it. This is yet another one that has part of its origin.
Sorry, what did you say it inserted on?
Oh, the palmaris longus?
Hmm?
Yep, it inserts into the palmar aponeurosis, which is just this sheet of tendon in the middle of the palm. So it's not actually inserting on a bone.
Okay.
In a lot of people, do we have to learn it?
What's that?
If it's absent in like a lot of people, do we have to learn it?
Well, it's when I say a lot, it's actually a minority of people who have it, who are missing it. It's only absent from about 14% of the population. So that means that 86% of the population will have it. So you do still need to know it. All right, flexor carpi ulnaris. Well, we've already talked about what flexor means. You know what that is, and carpi is hand. So this is another flexor of the hand. But it's a flexor of a hand that's on the ulnar side, which is the more medial side of the forearm. And if you followed it all the way down to its insertion, it's inserting down here on the base of the fifth metacarpal. That's the metacarpal associated with the pinky finger. So that's way over on the medial side of the hand. So this is another muscle that's going to flex the hand at the wrist joint. It just happens to be located more on the medial or ulnar side of the forearm. And if I can clear my drawings. Now, I didn't say anything to you about innervation yet, as I've described these muscles of the anterior forearm. I did mention brachioradialis is innervated by radial nerve, but these are the true anterior compartment muscles. A simple way to remember the innervation of these anterior compartment muscles, and there's a bunch of them, we're going to talk about a few more of them in just a minute, is that most of them are innervated by the median nerve. Most of the anterior compartment muscles of the forearm are supplied by median nerve. There are only 1.5 muscles in the anterior forearm that are supplied by the ulnar nerve. So all except 1.5 of these anterior compartment muscles are supplied by median nerve. Only 1.5 are supplied by ulnar nerve. And flexor carpi ulnaris is one of the muscles that's supplied by ulnar nerve. So that's supplied by ulnar. Everything else, pronator teres, flexor carpi radialis, palmaris longus, those are all supplied by median. All right, before we move on, I should make another point too. I mentioned that the two flexor carpi muscles are both involved in flexion of the hand. And if both of these muscles work together at the same time, then you get just plain old flexion of the hand at the wrist joint. So if flexor carpi ulnar or radialis and flexor carpi ulnaris are working together, then you just get plain old flexion of the hand at the wrist joint. But it's also possible for these muscles to work by themselves and not work together in unison. And when that happens, you may get flexion, but you may also get a different motion. They can be responsible for, or they can participate in the motions of abduction and adduction of the hand at the wrist joint. So if the flexor carpi radialis were to act all by itself, since that muscle is inserting more on the lateral side of the hand, when you pull up on the lateral side of the hand has a tendency to rotate in a lateral direction, which would be abduction with B of the hand at the wrist joint. So flexor carpi radialis can be a flexor of the wrist, but it can also be an abductor of the wrist. Flexor carpi ulnaris is just the opposite. That muscle is inserting over here on the medial aspect of the hand. So if the flexor carpi ulnaris were to contract all by itself, it would have a tendency to lift up on the medial side of the hand, which is going to rotate the hand in a medial direction, which would be adduction with a D. All right, let's move on to, come on. Get this thing to turn off. Come on. The next layer of muscles in the anterior compartment of the forearm is really just a single muscle. There's a muscle known as the flexor digitorum superficialis. That's another one that's kind of a mouthful. It's a rather long name. But if you break down the meaning of the name, it's a little easier to keep track of what it does. So flexor, we know it's flexing something. Digitorum, digitorum is the plural in Latin for digit. So all of your fingers are the digitorum. So it's a flexor of the fingers. Superficialis simply means that it's the more superficial of the flexors of the digits. So it turns out you actually have two muscles that are responsible for flexing the fingers. This is the more superficial one, and we'll see in just a minute that there's also a deeper one that lies deep to it. The flexor digitorum superficialis has a rather complicated origin. I think you may be able to tell that up here, it also has part of its origin on that common flexor tendon coming off the medial epicondyle of the humerus. It also has a deeper origin coming from the proximal end of the ulna as well, but we probably won't see that. And then finally, it has this really long origin over here. There's this long, broad tendon of the muscle, which is originating from the shaft of the radius over on the lateral side of the bone. And then all of that comes together to form this big, broad, flat muscle belly. By the way, in lab today, once you've dissected the superficial muscles and you start working your way down into this deeper layer, the dissector is going to tell you to cut part of the origin of this muscle. The description in the dissector is rather confusing. What they want you to do is cut this attachment. They want you to cut the origin of the flexor digitorum superficialis from its origin on the radius. And what that's going to allow you to do is take the whole muscle and reflect it medially towards the body so that you can see some of the deeper stuff. So complicated origin, common flexor tendon, long origin on the shaft of the radius. If you follow the tendons of the muscle distally, it eventually splits up into a total of 4 tendons down here just before it crosses the wrist. Now, right now in this drawing, you can only see 2 tendons. That's because they're stacked on top of one another. If you were to look at a cross section through the wrist, you'd see that there are 2 tendons superficially and then 2 other tendons just lying deep to it. So they're stacked like this, 2 and 2. These tendons cross the wrist. They actually pass through a space known as the carpal tunnel that you may have heard of before. And eventually they pass into the hand, and they're going to continue all the way out to insert on the middle phalanx. That's that middle finger bone in digits 2 through 5. So that would be your index finger, middle finger, ring finger, and pinky finger. So this muscle has nothing to do with the thumb. It doesn't go to digit 1, which is the thumb. It's only going to flex digits 2, 3, 4, and 5. And specifically, it's inserting on what's known as the middle phalanx, that middle finger bone of those digits.
Question.
Yeah.
So flexor digitorum, that one has 4 tendons, right?
Flexor digitorum superficialis has 4 tendons, correct?
Okay, and we can only see 2, but the other 2 are underneath it.
That's right. Exactly.
Oh, okay.
Yep. Just quickly, the innervation of flexor digitorum superficialis. The entire muscle is innervated by median nerve. So I mentioned before that most of the muscles in the anterior compartment of the forearm are innervated by median nerve. We've only seen one exception to that so far, which is flexor carpi ulnaris, which is innervated by ulnar nerve. All right, once you've detached the flexor digitorum superficialis from its origin on the radius, and you can actually see that here. This cut tendon right here represents the flexor digitorum superficialis reflected off of the radius. Then you'll be able to see some of the muscles that lie in the deepest layer of the anterior compartment. And there are 2 shown here. There's a third one that I'll show you, I think, on another slide. Flexor digitorum profundus. So it's another flexor of the fingers, but it lies deeper. This originates primarily from the ulna, and you can see that here. It may also have part of its origin from the interosseous membrane between the bones. If you follow it distally, you can see that it's also dividing into 4 tendons, but these 4 tendons lie side by side instead of stacked on top of one another. And in this particular picture, you can follow those tendons all the way out to their insertion. Here's one of those tendons coming all the way out. It passes under this little Y thing, goes right through the middle of the Y, all the way out here to the distal phalanx. And that's going to be true of all of these. All 4 tendons of flexor digitorum profundus insert on the distal phalanx of digits 2, 3, 4, and 5. This is another muscle that's going to be responsible for flexing some of those joints of the digits. By the way, that little Y-shaped thing that you can see in this picture on each of the digits, that's the tendon of the flexor digitorum superficialis that we just talked about on the previous slide. Those flexor digitorum superficialis tendons come down, and each of those tendons actually splits to form this Y-shaped structure. And this is inserting on the middle phalanx of each digit. And then that split then allows the profundus tendon to pass through the middle of the split to continue out to the distal phalanx. So flexor digitorum superficialis, the one that has this Y-shaped split, it's inserting here on the middle phalanx, which means it can flex metacarpal phalangeal joints. It can flex the it can flex the carpometacarpal joints. It can flex the metacarpal phalangeal joints. It can flex the PIP joints or proximal interphalangeal joints. But the superficialis ends at the middle phalanx. It doesn't continue all the way out to the distal phalanx. So it can't, the flexor digitorum superficialis can't flex the dip joints, the distal interphalangeal joints. The flexor digitorum profundus is the one that continues all the way out to the distal phalanx. So that's the muscle that would be able to flex the dip joints as well. Now, flexor digitorum profundus has an unusual innervation half of it is innervated by median nerve, along with most of the other muscles in the anterior forearm. But half of it is also innervated by ulnar nerve. So I mentioned earlier that the ulnar nerve innervates only 1.5 muscles in the anterior compartment. So one muscle would be flexor carpi ulnaris, and then the half a muscle innervated by ulnar nerve would be half of the flexor digitorum profundus. And specifically, it's the medial half, which is closer to the ulna, which is innervated by ulnar nerve. And that part of the muscle is what sends tendons to digits 4 and 5. The other half of the muscle over on the lateral side, and let's see if I can pull up a different color. Oh, that's a lousy color. The other half of the muscle over here, the lateral side, which sends tendons out to digits 2 and 3, that half of the muscle is innervated by median nerve. The last muscle that's shown here is a muscle called flexor pollicis longus. It's a flexor. What the heck is a pollicis? The Latin word for your thumb is pollex. So pollicis is an adjective referring to anything that has to do with the thumb. So we'll see there's a whole bunch of muscles that are actually involved in movements of the thumb. Now it also has the word longus in it. And we'll see this quite frequently in other parts of the body, that oftentimes there are two muscles that do the same thing, but one of them's longer and one of them's shorter. So this is the long flexor of the thumb. There's also a very short flexor of the thumb, which is located actually down here in the palm of the hand, and it's much, much shorter. So you can see there's a real extreme difference between the long flexor and this little short flexor down here. We'll come back to that short flexor at another time. So flexor pollicis longus, it flexes the thumb, and it's the longer one that flexes the thumb. It's originating primarily on the radius, and it has its insertion way out here on the distal phalanx of the thumb. So it's crossing all of the joints of the thumb, meaning it can flex all of the joints of the thumb. So it can flex the carpometacarpal joint, it can flex the metacarpophalangeal joint, and it can flex the single interphalangeal joint in the thumb. Now here's another view of a couple of those muscles I just talked about. Flexor digitorum profundus over on the medial side. You can see how it splits into its 4 tendons down in the wrist. Those are passing through the carpal tunnel as they pass through the wrist. Then over on the lateral side, on the radial side, you can see flexor pollicis longus, which would be sending its tendon down to the distal phalanx of the thumb. But it's been partly cut away in this picture to show the final muscle in the anterior compartment, which is this muscle called pronator quadratus. Pronator quadratus gets its name from the fact that it's square. So it's quadratic or quadrilateral. So you can see that it has this kind of square shape under here. It has its origin on this side of the forearm, on the ulna, and has its insertion over on this side, on the radius. Just looking at the muscle, it would be hard to know, well, why is this called origin and why is this called insertion? Why isn't it the other way around? Because you may recall that the origin is usually the part that remains stationary, that stays fixed, and it's the insertion that moves. Well, this muscle moves the radius relative to the ulna as you pronate the forearm. And you might also remember, if you were paying attention earlier in today's lecture, the ulna doesn't move when you pronate and supinate the forearm. All of that motion is movement of the radius moving relative to the ulna. So that's why the ulna is considered the origin, because that end of the muscle doesn't move, it stays stationary. It's the other end of the muscle that moves as the radius is pulled across to the other side of the ulna. And so it's a pronator muscle that happens to be square shaped. So it pulls the radius across the distal end of the ulna during pronation. This is yet another muscle that's innervated by median nerve in the anterior compartment of the forearm. A couple of other things to note on here. You've got the ulnar nerve over on the medial aspect of the forearm, and that's innervating just 1.5 muscles in the anterior forearm. Just the flexor carpi ulnaris, which is the most medial muscle of the forearm, and also this medial half of flexor digitorum profundus. So it's not really surprising, you know, ulnar nerve is running down the medial aspect of the forearm. So it's not surprising that it would innervate muscles that are more on the medial side. Here's the median nerve up here, which runs right down the midline of the forearm. And that innervates all of those other anterior forearm muscles that we've talked about. Median nerve also gives off a branch called anterior interosseous nerve. And specifically, this is the nerve that's innervating these deeper muscles. But I'll tell you right now, if I ask you a question about innervation of these muscles, I'm not going to expect you to be real specific and say, oh, pronator quadratus is innervated by the anterior interosseous branch of the median nerve. Just as long as you know it's innervated either directly by the median nerve or by one of the branches of the median nerve, that's all I expect. All right, gotta close my thingy here. All right, so we're going to move on now to talk about the posterior compartment of the antebrachium, which also has, as you can see from this slide, a whole bunch of muscles. I'll make it easy for you about innervation of these. I'll just get that out of the way now. Some of these are innervated directly by the radial nerve. Some of them are innervated by a branch called the deep branch of the radial nerve. Others are innervated by something called the posterior interosseous nerve, which is also a branch of the radial nerve. But as far as I'm concerned, as long as you know that all of these posterior muscles in the antebrachium are all innervated by radial nerve or by one of its branches, that's good enough. Now, interesting thing about the posterior muscles, I mentioned way back at the beginning of the lecture that the posterior muscles, they're posterior to the forearm, but they've also migrated somewhat more towards the lateral side of the forearm. Many of them have their origin on something called the common extensor tendon. Now, in the anterior forearm, we saw that a lot of muscles had their origin on something called the common flexor tendon, because the anterior muscles are all flexors of the wrist and fingers. Here on the posterior surface, we have something called the common extensor tendon, because most of these muscles are involved in extension of the wrist and extension of the digits. And this common extensor tendon is coming off of the lateral epicondyle of the humerus. All right, so just as I did on the anterior side, I usually have to try to find some landmark or something and work my way across the forearm from one side to the other in order to be able to identify the muscles, because they all look so similar to one another. So I, again, typically look for the thumb, because I know that's going to be on the lateral side, and I work my way across the posterior forearm from lateral side to medial. So starting laterally, really the most lateral muscle in the posterior compartment is the brachioradialis, but that's the one that's gone so far around the lateral side that it ends up all the way around to the front of the forearm. You can't even see it in this posterior view. So brachioradialis is a posterior forearm muscle, but we already talked about it because you can see it from the front. So these are the first muscles that you really get a glimpse of as you look at a posterior aspect of the forearm. And it starts with two muscles called extensor carpi radialis muscles. So these are extensors. They extend something of the hand, carpi. Radialis refers to the fact that they are closer to the radial side or lateral side. But now there are two of them. On the flexor side, we only had one flexor carpi radialis muscle. But here on the extensor side, we have a longus and a brevis, which are distinct from one another. The longus is a little bit more superficial. The only reason it's called longus is because it originates a little higher up on the humerus. It's originating specifically from the lateral supracondylar ridge of the humerus up here above the epicondyle. And if you were to follow extensor carpi radialis longus all the way down into the hand, let's see if I can, there it is. It's inserting on the second metacarpal in the hand. Just deep to the radialis longus is extensor carpi radialis brevis, right here. That's originating on that common extensor tendon coming off the lateral epicondyle. And if we follow it down into the hand, you can see it inserting right there on the third metacarpal of the hand. So this muscle is going to extend the wrist or extend the hand at the wrist. But notice that it's also running along the lateral side or thumb side of the wrist, and it's inserting here a little closer to the lateral side of the hand. So when this muscle contracts, it's also going to have the effect of rotating the hand laterally or rotating it away from the body, which would be abduction with a B. All right, continuing to work our way across the posterior aspect of the forearm. The next muscle we come to is called extensor digitorum. So it's an extensor of the digits, an extensor of the fingers. Now you might notice there's no other word here. It's not extensor digitorum superficialis or profundus or anything like that. On the flexor side, we had two different flexor muscles. There was a flexor digitorum superficialis and a flexor digitorum profundus. But here on the extensor side, in the posterior compartment, there's only one extensor of the digits. So it's just extensor digitorum, and there's no other word to modify that. So just a single extensor of the digits. That also has its origin up here on the common extensor tendon. And if you follow the tendons down, they all insert out on the distal phalanx of digits 2, 3, 4, and 5. So they extend all of the joints of those digits. Now, even though we don't have a separate superficialis and profundus to extend the digits, there are a couple of additional extensor muscles that are involved with extension of specific fingers. So there's a muscle that lies just medial to extensor digitorum. It's a very thin, tiny little muscle called extensor digiti minimi. I love that name. So it's an extensor of a digit, but minimi means little or littlest. So this is a muscle that specifically extends just the fifth digit, the fifth finger. So the muscle is also originating on that common extensor tendon, but if you follow its tendon, it goes all the way out to the distal phalanx of digit 5 specifically. So it's involved in extending the joints just of the little finger. And finally, working our way across all the way over to the medial side of the posterior compartment, we come to a muscle called extensor carpi ulnaris. And remember, on the flexor side in the anterior compartment, we had a flexor carpi ulnaris, which flexed the wrist on the ulnar side. Here we have an extensor of the wrist, or an extensor of the hand on the ulnar side. So it's an extensor of the hand on the ulnar side, meaning it's on the medial side of the forearm, which is the side with the ulna. So that also originates up here on the common extensor tendon. You can actually see its tendon right here, and it inserts right there on the 5th metacarpal of the hand. So when this muscle contracts, if it's working along with these other extensor carpi radialis muscles, you're going to just get pure extension of the wrist. But if extensor carpi ulnaris is contracting all by itself, it's going to have a tendency to pull up on the medial side of the hand, which is going to rotate the hand medially towards the body, which would be adduction, adduction with a D. Trying to get rid of this little menu there. Okay, there we go. All right, in addition to the superficial muscles in the posterior forearm, there's also a bunch of deeper muscles. And I think you can tell right now that this is complicated stuff. There's a ton of muscles to know here. There's a muscle called extensor indicis, or sometimes people might call it extensor indicis. There's some confusion about the pronunciation of the word. But extensor indicis is originating from the ulna, and it sends a tendon all the way out to the distal phalanx of digit 2, which is the index finger. That's where the name comes from. Indicis is an adjective referring to index, as in index finger. So just like the extensor digiti minimi was a muscle involved just in extending the pinky, you also have this deeper muscle here involved in just extending the joints of the index finger. So it's relatively easy to extend your index finger and your pinky finger independently of the other digits. But if you try to extend just your middle finger, or especially your ring finger, it's very difficult to extend any one of those digits independently of the others. Some other muscles that lie in this deeper layer in the posterior compartment. There's an extensor pollicis longus. So remember, it's an extensor of the thumb, and it's the longer one. Right next to it is extensor pollicis brevis. So it's an extensor of the thumb, and it's the shorter one. These lie pretty much side by side. And the extensor pollicis longus gets its name from the fact that its tendon goes all the way out to the distal phalanx of the thumb, whereas the extensor pollicis brevis, its tendon only goes out to the middle phalanx of the thumb. So that's really the main reason for the difference in names. And because of that, these can extend different joints of the thumb. Running right alongside of the extensor pollicis brevis is the very last muscle called abductor pollicis longus. So it's an abductor of the thumb, and it's the longer one. Remember that abduction of the thumb is actually that motion of pointing the thumb forward, so it's sort of perpendicular to the rest of your hand, so lifting the thumb up out of the flat plane of the hand. So this muscle would be doing that. It would be causing the thumb to point forward, perpendicular to the rest of the hand. Now it's called longus. So whenever there's a longus, there must also be a brevis somewhere. But we don't see any brevis here, and we've run out of muscles. There is no brevis here in the posterior forearm. The abductor pollicis brevis is actually located in the palm, and we'll see that when we talk about or dissect the hand. The tendons that I just described, specifically the two extensors of the thumb and that abductor of the thumb, Those tendons form an anatomic space, which has kind of a silly name, but anatomists refer to this as the anatomical snuff box. And one of these days, I have to research this and figure out why they call it that exactly. It might be because people used to use this little indentation at the base of the wrist to hold snuff, and they would hold it up to their nose and snort stuff in. Or alternatively, it could be that this arrangement of tendons looks like the little boxes that people used to use to carry snuff around. By the way, if you're not familiar with snuff, it was smelly stuff like tobacco or chopped up flower petals or something like that. People would carry it around with them and they would snort it up their nose to make other people smell better, because this was in the days before personal hygiene and the days before deodorant. So everybody stunk really bad. So rather than cleaning yourself and using deodorant to smell better, you just snorted this stuff up your nose so that you couldn't smell anybody else. But anatomists have borrowed that term to describe this anatomic space that lies between some of these tendons. So you have that extensor pollicis longus tendon coming from the back of the forearm all the way out to the distal phalanx of the thumb. And then you have extensor pollicis brevis tendon also coming from the back of the forearm, but stopping right here at the middle phalanx of the thumb. And between them is actually a bit of an indentation or space. And if you extend your thumb, you may actually be able to find this little pocket near the base of your thumb, right where your thumb kind of meets your wrist. There are some structures found in the anatomic snuff box, and your book is the dissector is going to ask you to look for these. This nerve that's running over the top of this area is called the superficial branch of the radial nerve. It's a sensory nerve to the skin here on the back of the hand. And then that artery that's passing through the floor of the snuff box is called the radial artery. That's an artery that originates way up near the elbow, but it comes all the way down into the hand and it crosses through the floor of the snuff box right here. All right, we're pretty much out of time, but just really quickly, I want to run through the nerves that continue down into the antebrachium, and I can describe them very quickly, so I'll just take a minute to do this. We've already talked a little bit about how the musculocutaneous nerve is primarily a motor nerve to the muscles in the anterior compartment of the brachium, like biceps brachialis and coracobrachialis. But after it finishes innervating all those muscles, it continues down into the forearm, where it's just a sensory nerve. And many of you saw this in lab the other day. And you can see in the little green shaded area, the area of skin on the lateral aspect of the forearm that would be supplied by this nerve. So sensation from that area of skin would pass through the lateral antebrachial cutaneous nerve. And then actually from there, it would go all the way up to the spinal nerve at C6, because that's also part of the C6 dermatome. The median nerve doesn't innervate anything at all in the brachium. It doesn't supply any skin or any muscles in the upper part of the arm. It's just kind of passing through. But once it gets down into the antebrachium and into the hand, it does a lot. It innervates, as I said earlier today, it innervates all of the muscles in the anterior compartment of the forearm, except for 1.5 that we'll talk about in a minute. Then it continues through the wrist and innervates 5 muscles in the hand. It's also a sensory nerve to the skin of the lateral palm, as well as digits 1, 2, 3, and part of digit 4. So that's thumb, index finger, middle finger, and part of the ring finger. The ulnar nerve also innervates nothing in the brachium. The ulnar nerve doesn't innervate any muscles or any skin up in the brachium. It just passes through the brachium on its way down into the forearm. When it gets into the forearm, it lies in that space that you can see there between flexor carpi ulnaris and flexor digitorum profundus. It innervates the entire flexor carpi ulnaris, and it innervates half, the medial half, of flexor digitorum profundus. So it's innervating only 1.5 muscles in the anterior compartment of the forearm. Median nerve supplies all the other muscles in the anterior forearm. But once the ulnar nerve crosses the wrist into the hand, it does a lot. It innervates 14 separate muscles. that are located just within the hand itself. And it's also a sensory nerve to the skin on the medial aspect of the hand, including part of digit 4 and all of digit 5, the pinky. And finally, the radial nerve. The radial nerve, you remember, comes off the posterior cord of the brachial plexus. It passes posterior to the shaft of the humerus, but then it comes back around towards the front of the elbow over on the lateral side. You can find it lying in between the brachialis and brachioradialis muscles. At this point, it splits into 2 branches, superficial and deep. The superficial branch is a sensory nerve, which is going to travel all the way down to the dorsal surface of the hand. So it's a sensory nerve to the posterior or dorsal aspect of the hand. The deep branch of the radial nerve is going to dive deep into the muscles in the posterior compartment, where it's responsible for innervating all of those posterior compartment muscles. So it does change names a couple times. First, it's the deep branch of the radial nerve, and then it becomes posterior interosseous nerve a little bit farther down. But all of these branches, radial, deep radial, and posterior interosseous, together they innervate all of the muscles in the posterior aspect of the antebrachium. The radial nerve is also responsible for sensation to most of the posterior aspect of the upper limb. So there are branches of radial nerve that supply the back of the brachium. There's another branch of radial nerve responsible for the posterior antebrachium. And then finally, you get that superficial branch of radial nerve supplying the posterior surface of most of the hand. All right, so that's it for today. Sorry to go over a few minutes. Any quick questions before we take off to get to lab? I'm going to assume that's a no. And so people are going to want to run off to lab. So I'll see you in lab in about 40 minutes.